Swayam Prabha. Digital India. Educated India.
So, from memory management, let us move on to file systems, how we store data on disk. So, in this module on file system management, we would be discussing precisely that, how data are stored on secondary storage media, how we store files and other information on the disk, how we manage storage space and so on. So, we start with some basic information about secondary storage media, because understanding how a secondary storage media like the disk works is very important. Once you understand how a disk works, because today, as of today, still the most widely used secondary storage media is the disk. Of course, we are having a gradual shifting, as you would all know, to something called solid state disks. Okay? But still disk is the most predominant form of secondary storage media. So, we start with that discussion. So, talking about secondary storage media, we discuss the most common kind of storage media that we use in our computer systems today, which is the magnetic disk. Sometimes it is also called the hard disk, because the surface of the disk is hard, it is not flexible. Now, magnetic disk is in place for many decades. It is a traditional way of storing information on a recording surface with a layer of ferromagnetic material. So, data are stored as very tiny magnets. Depending on which side is the north pole or which side is the south pole, you can store either 0 and 1. So, basically we are using some kind of magnetic technology to store information. Now, over the years, several kinds of this kind of magnetic recording media have evolved. Some of them have become obsolete, you do not see them anymore, some of them are still there. Like floppy disk is something which was there till even a few years back. Floppy disk is a portable kind of a storage media which is removable, and it is built using bendable plastic. So, if you break open a floppy disk, you will find that there is a circular kind of a plastic with some kind of black color coating on both the sides, and it is flexible, you can bend it. Okay. So, on the surface of the floppy disk you can record the data, as I had said, by making tiny magnets. Magnetic drum was a media which was there in the first generations of computer systems, but now we do not see magnetic drums anymore. It is like a drum, like a cylinder which rotates at a high speed, and some read write heads on the surface of the drum, they can read or write data. Of course, what we see today mostly are the hard disk, sometimes we call it magnetic disk. These are, as the name implies, hard, and they are made of metal or glass with some ferromagnetic coating on top of it. And all these three media, the basic concept is the same. There is some kind of a rotating platter. The disk or the recording surface rotates in some way, and there is a read write head which sits on top of the surface, and using the read write head you can either read the direction of magnetism, so what is stored, or you can write new data on the surface of the disk. So, basically there is a rotating platter and there is a movable read write head. The read write head can move over the surface of the disk, and as I had said, data are stored on these surfaces as tiny magnets. Okay. This is how data gets stored in magnetic disks. Now, these are some of the pictures. You see, the first picture on the left shows a magnetic drum. So, you see that there is a cylindrical kind of a thing on the surface of which the data gets recorded, and there are read write heads sitting on the surface of the drum. And floppy disks, here we are showing two types. This was the older version 8-inch and this was the newer version 3.5-inch. This is how they look like. As I said, inside there is a flexible plastic kind of a material with a ferromagnetic coating on top of it. And the magnetic discs that we see today, earlier the magnetic discs were much larger in size, but nowadays we have 3.5-inch or even smaller 1.8-inch and so on. So, on the right you see a magnetic disc with the cover opened. Inside it looks like this. This is the recording surface you can see, and this is the read write head you can see here. So, read write head can do reading and writing on the surface of the disc, and the disc rotates at a high speed. Nowadays, as I have said, that we are slowly phasing out this magnetic technology and we are moving to something called solid state disk. We call it still disk because disk, the name disk is some kind of a legacy, but it is a solid state storage media. So, on the bottom you see this is a semiconductor device, it is a small card or a board which you plug into your computer system, and this is equivalent to a disk, and they are much smaller in size, much lighter, there is no moving parts, and also they are faster. There are a number of advantages you have here. Okay. Fine. Now, coming back to hard disk. In a hard disk, as I said, the surface or that is called a platter, they are made of rigid material, either metal or glass. They cannot bend. Because they cannot bend, we can rotate it at a very high speed. They have several advantages over floppy disk, because floppy disks were soft, flexible, that is why you could not rotate it at a very high speed. And because they are rigid, you can have even larger size hard disk if you want to, and also you can have higher density because the size of the magnets you record on the surface can be smaller. You can very accurately position the read write head and you can create very small magnets on the surface. So, the recording density on the surface can be much higher, and I said as it spins much faster, several thousands revolutions per minute, that is the typical speed of revolution. So, you can have a higher data transfer rate, but for a floppy disk the revolution speed was much smaller. Okay. But there is an interesting thing here. In case of a hard disk, as I said, there is a read write head which is sitting on top of the surface of the disk, but as the disk is rotating at a very high speed, several thousands revolutions per second, it carries a thin layer of air with it. So, the read write head does not get in physical contact with the surface, it floats on a very thin layer of air, several microns wide, and it actually floats on the surface of the disk. There is no physical contact. This is how the read write operation works. The read write head sits on the surface on top of a thin air cushion. Okay. As I said, the air cushion is typically few microns wide, and because of these accurate kind of a mechanism, very thin layer of air, you cannot afford to even have a speck of dust inside that enclosure, because the size of a dust particle can be of the order of few microns. So, if a speck of dust falls on the surface, the read write head can fall on the surface, it can crash with that speck of dust. Okay. So, you need a dustless environment, and because of that the disk provides much higher reliability. And in general, not only one platter inside a disk unit, there can be multiple such recording surface, multiple platters. Okay. Now, let us see how data are organized in a hard disk. This is interesting. As I said that in a disk there are number of platters. Platters are circular plates. I think for those of you who have seen the earlier records where you used to play music, so it looks something like this. So, if you look from the top, the view is circular with a hole in the middle. Okay. And as I said, there are number of platters, each platter has two surface, top and bottom. You can do recording on both the surfaces. So, the first thing is that each platter, there can be multiple platters, each platter has two recording surfaces, and as I said, the platters can come at in various sizes. There are very small hard disks with of the order of 1 inch diameter, it can be as large as 8 inches also, even larger, earlier disks were even larger. And as I said, these platters, there is a mechanism, there is a motor which makes it rotate at a very high speed. Not just one platter, all the platters which are sitting on top of the other, all of them rotate together. So, this stack of platters, they rotate together at high speed, typically 5400 to 10,000 revolutions per minute. This is the typical speed of the hard disk units that are available in the market. And how you do recording on the surface? Each recording surface, each surface of the disk, each surface of the platter is divided into concentric circles which are called tracks. So, tracks will look like this, this is one track, this is another track, like this. There can be a large number of tracks on the surface. The number of tracks on the surface depends on the disk again. It can vary from, let us say, of the order of 1000 to 5000. These are very typical figures. And even inside the track, you divide the track into several segments, and each of these segment is called a sector. This is a sector. Each track is divided into a number of sectors. Typically, in each track you can have, let us say, from 64 to up to 200 sectors. These are again typical values, and you store data sector wise. In every sector you can store, let us say, from 512 to 2048 bytes. These are typical values. And when you are doing some reading or writing operations on the disk, you cannot read a single byte, you cannot write a single byte. When you want to read, you have to read a complete sector. When you want to write, you will have to write a complete sector. So, sector is the basic unit of information using which you can do the read and write operations. So, this is important to note. Sector is the smallest unit of data using which you can do IO operations on the disk. And if you imagine that there are multiple platters sitting one on top of the other, if you consider the same track number on all the surfaces, let us say track number 10 on all the surfaces, they will look like a cylinder, one track here, one track on top of it, another track on top of it. So, all look like a cylinder. So, all the tracks same track number under the head at a given time, because the read write heads all move together, there is one read write head per surface, they move all together. At a time, the read write head is sitting on top of any one particular track on all the surfaces. Let us say track number 10. So, all the track number 10s taken together is called a cylinder. The notion of a cylinder is that because there are multiple read write heads, you can carry out parallel read or write operations on the different surfaces at the same time. And as I said, all the disk heads on all the surfaces, they are connected together and they move together forward and back. Okay. So, pictorially, as I said, it looks like this. There can be multiple platter. In this diagram, I am showing 3 platters, 1, 2 and 3. 3 platter means there will be 6 surfaces, top and bottom, and on each platter there will be multiple tracks. One track is shown, this is the track, the yellow color, and inside the track there can be multiple sectors. So, one sector is shown here, and the same track number on all the surfaces taken together is a cylinder. These are some of the notations that we use. Okay? Fine. Now, when you do read write operations on the disk, it takes some time. We call it the access time. Now, access time in a disk consists of a number of different components. Let us try to understand that. There are distinctly 3 components of access time. See, you again just imagine the surface of the disk. There are a number of tracks. There is a track here, there is a track here, there is a track here. There can be hundreds of such tracks. Now, as I said, the read write head moves forward and backward on top of the track. See, on the diagram on the right, you can see the read write head here. This is the read write head. The read write head using an accurate motor, this is a motor, a stepper motor. Using a stepper motor arrangement, the read write head can step forward or step backward. You can very accurately position the read write head on top of a particular track. Okay. Now, at a particular point in time, the read write head may be on top of some sector let us say track number I. Suppose next you want to read data from a track or a sector which is on a track which is on some other track j. So, you will have to move the read write head from I to j. So, that is a physical movement, mechanical movement. That mechanical movement takes a few milliseconds. That is what I call as seek time. The time taken for the read write head to move to the track on which your requested data is there. So, it is the time required to move the read write head to the desired track. As I said, because it involves mechanical movement, it cannot be very fast. It typically takes several milliseconds. But this time that I am showing, it is the worst case. From one end of the disk, if you want to move to the other end, what is the maximum time? But on the average, you may not have to move through all the tracks, because you may already be in the middle, maybe you will have to move through 10 tracks only. So, the actual time may be much less than that. Okay. So, this is the first component of the time, which is seek time, to move the read write head on top of the track where your data is stored. Fine. Now, the second component is rotational delay. See, you again imagine the surface of the disk. There is a particular track, let us say this is a track on which your read write head has already been positioned. Your read write head is sitting on top of the track. As I said, your disk is rotating at a very high speed. Now, on the track there are a number of sectors. Okay? I told that there are a number of, it is divided into a number of sectors. Suppose the read write head is here and you want to access this particular sector. So, after you reach the desired track, you will have to wait for the desired sector to rotate under the head. Only then you can read the sector, right? Because the sector can be at the other end. Let the disk rotate, the sector come under the read write head, then only you can read. This is called the rotational delay. In the worst case, you may have to wait almost an entire rotation, because the sector has just crossed the head. You will have to wait for the entire rotation to again for it to come under it. In the best case, it can be just adjacent, immediately you will get it. On the average, you will have to wait for half the rotation. Okay. So, the average rotation delay will be the time taken for half the rotation. Now, as I had said, disk units come with various speeds, that is the rotational delay. Let us say here I have shown calculation for 3 different typical values: 3600 revolutions per minute RPM, 5400, 7200. Of course, nowadays disks with about 10,000 RPMs are also available. So, to find the average rotational delay, let us say for 7200 RPM, so how do you calculate? You just calculate one revolution will take 1 minute. So, on the average, as I said, the average rotation delay will be half revolutions. So, half revolutions will be how many minutes? You can calculate this, convert it to milliseconds. You will find that the time comes to about 4.15 milliseconds. For 5400 RPM it is 5.53, for 3600 it is 8.30. So, faster the disk rotates, less will be your time you will take to carry out read or write operations. Okay. So, these are the two main components. One is moving the read write head on top of the track, second the sector to rotate under the read write head, that time, that is the rotational delay, sometimes it is called the latency, rotational latency. Okay. And third is the actual transfer time, because you see again if you look at a surface, a track and a particular sector, let us say this is a particular sector you are wanting to read. So, after you reach a sector, the read write head is on top of a sector, then you start reading the data bytes of a sector. Let us say your sector size, let us say your sector size is 2048 bytes. So, how much time is required to actually read those 2048 bytes? That is the actual transfer time. After the seek time and rotational delay, the actual data transfer will start, that is the transfer time. So, that is basically the time taken to transfer one unit of data. As I said, in a disk the unit of data is a sector, and depends again on the speed of the disk, how fast it is rotating and how densely you are recording it on the surface, how small or how big the sectors are, lot of things are there. Your transfer rates can vary, typically it is of the order of few megabytes per second, as I said 15 megabytes or even more. And the transfer time, of course, it depends on how big or how small are your sectors, how fast your disk is rotating and how small your magnets are, that is the recording density on the surface of the tracks. So, all these three times taken together will determine how much time will be taken to read some data from the disk or write some data into the disk in terms of a sector. Okay. As I said, everything happens on the disk in terms of sectors, that is the basic unit of information. Okay. Let us work out a small example to indicate how much will be the transfer rate. Let us consider a disk with some parameters. We assume that every sector can hold 512 bytes, that means our sector size is 512 bytes. 200 tracks per surface, so 2000. So, tracks per surface is 2000. And 64 sectors per track. Sectors per track is equal to 64. And also we assume that the 3 double sided platters. So, how many recording surface will be there? 6. So, number of recording surfaces, there are 3 recording platters, on each platter there are 2 surfaces. So, it is 6. So, the first question is, what is the total capacity of the disk? Total how much data the disk can hold, first question. See, it directly comes from these figures which have been provided. You have 6 surface, on each of these surfaces you have 64 means you have 2000 tracks. In each of the track you have 64 sectors. In each of the sectors you have 512 bytes. So, step by step if you calculate, firstly number of bytes in every track. There are 512 bytes in every sector, and in a track there are 64 sectors. So, if we multiply it, see 512 multiplied by 2 is 1k, that is our definition. We take powers of 2, 1k we denote it as 2 to the power 10, which is 1024. So, this comes to 32k, 32 kilobytes. This is per track. Now, on every surface, what will be the total capacity, bytes per surface? See, in each track you have 32 kilobytes of data. As is mentioned, there are 2000 tracks. So, if you multiply, it comes to 64,000 kilobytes, that is the total capacity. Okay. So, the total capacity of the disk will be the capacity of one surface 64,000 K multiplied by number of surfaces, which is 3 into 2. So, if you multiply, the figure comes to like this. So, which is approximately 384 megabytes. So, you can understand modern day disks comes with capacities of gigabytes, right, very large gigabyte value. So, these figures must be much higher, because these are very typical figures I have shown as an example. The number of tracks, number of sectors, sectors per track, the capacity of each sector, they are much higher in modern day disks. That is why the capacity is so much higher. We even have hard disk of capacity few terabyte, terabyte means 1000 gigabytes. Okay. Okay. Now that we have found out the total capacity of the disk, the second part of the question says, here the rotational speed is specified 7200. So, earlier we showed a calculation for a 7200 RPM disk, the average rotational delay is 4.15 milliseconds. So, what will be the transfer rate? Transfer rate will be with respect to a disk, capacity of a track, how much total track capacity is, which is 32 kilobyte, which we have already calculated, divided by the average rotational delay. Well, if you do not want to calculate average rotation delay, you can also take the complete rotational delay, which will be 8.3 milliseconds. So, you will be getting the actual data transfer rate. So, like this you can make a simple calculation, how much will be your data transfer rate, how much will be your capacity of the disk, and so on. Okay. Fine. Now, let us very briefly talk about solid state drives without going into the detail, because in all new laptops and in many desktop systems that you see today, you do not have any hard disk, we have something called solid state drives or SSDs. Now, if you open a laptop with a SSD, an SSD will look like this, very thin, very light. Even many of you have seen external hard disks. Now, external SSDs are also available, they are much smaller in size, very lightweight, there are no moving parts inside. And the USB pen drives that we use, they are based on the same technology. You can say SSD is like a pen drive, but it is sealed in an envelope, much more reliable. It is built to replace hard disks. These are sometimes also referred to as flash drives. Some of the features of this solid state, see these solid state drives are fabricated using semiconductor technologies, just like we fabricate transistors. Using the same technology we can manufacture these SSDs. Now, some of the features, important features are, it is non-volatile, which is one of the main requirements. Non-volatile means if we withdraw the power, the data that we have stored will not get destroyed. That is what I need in a disk, right? We need some kind of permanent storage. Once we store something, it will remain until or unless we change it. Secondly, it consumes very low power. You need power only when you are reading or writing, otherwise you do not need any power, because it is non-volatile storage. And the third important thing is that it is much faster than hard disk. That is why you will see in laptops where you have this kind of solid state drives, the time to boot the machine is much faster, just because of this. It can access the solid state drives in a much faster way, and in a disk you have the seek time, rotational delay. Here all those things are not there. You can directly go to the block which you want to read, you can directly read it. So, your speed of access is much faster, and this is also true for a disk, that when you read or write some data, they are typically accessed in terms of some blocks. And in solid state drives there is a very peculiar thing, whenever you want to write something, it follows a process. You erase the data first, then you do a write. You simply cannot write overwriting the previous data, you will have to do an erase cycle and you will have to do a write. Okay. And the technology that is used to build this kind of solid state drives is some kind of floating gate metal oxide semiconductor field effect transistor, which is called MOSFET. So, floating gate on pictorial on the right, it is shown like this. See, this is the typical picture of a semiconductor transistor, for those of you who are familiar with it, a p type transistor or an n type transistor. See, on one side you can have the source, this is the source, this is the drain, and in the middle there is a gate which is floating. Floating means there is an insulation layer, oxide layer on top and oxide layer on the bottom. It is floating, it cannot, and by applying a high voltage you can inject some charge on that floating gate. Because it is insulated, that charge gets trapped, it cannot leak, and that charge actually contains information whether you are storing a 0 or a 1. This is the basic principle of operation of a floating gate MOS transistor. You are injecting a charge into the device and that remains, and that charge will tell you whether you are trying to store a 0 or a 1. Okay? This is the basic technology. So, without going into the detail, now the main topic of discussion in this module is the design of a file system. How we store data in secondary storage in a computer system, how do we access them, some details regarding that. Now, some of the basic concept of a file system let us talk about here. Firstly, as I just now mentioned, that when you create some data on a computer system, we typically store them as files. There are a lot of editor. There is an editor, there are some word processors like Microsoft Word. In Unix you have so many VI and other editors, edit, gedit. You create files and those files are getting stored on secondary storage, let us say disk. So, whatever data you are creating, they are typically getting stored on secondary storage. And as I said, the basic unit of information that we use for storage are the sectors. So, suppose I want to create a file which is large, which consists of a number of sectors. Now, it is not necessary that all the sectors will be contiguous one after the other. Depending on the available free space on the disk, some sector may be allocated here, some sector on the next track, some sector on some other track. Of course, it is desirable to have them on the same track so that you can read them much faster, but in general the sectors can be spread all throughout the disk. And as we also know, when you store the files on a computer system, there is a concept of a directories or folders. You store them in folders, inside a folder you can create other subfolders. This is a good way to organize files, because instead of storing everything in one place, you can structure your files in different folders and subfolders. So, files are typically organized into directories and subdirectories. They are also called folders and subfolders. Okay. Now, we use the term file system. File system is a more comprehensive thing. Suppose I have a disk. If I think of a disk, I pictorially show it like this. Now, what is there inside the disk? We already saw. Inside the disk there are platters, there are tracks, there are sectors. There is a basic mechanism using which I can store some data using magnetic means, or if it is a solid state disk, using some other electronic means. Now, file system is some kind of a data structure. This we shall be slowly understanding about what kind of data structure you need, that you are storing on the secondary storage. We are not only storing the data, we are also storing lot of other information that will help us in accessing data, retrieving the data, managing data and so on. So, it is a file system is basically some kind of a elaborate data structure that gets stored on the secondary storage, and it is used to store files and directories, which are our main motivation. We want to store files. Not only that, it provides a set of functions using which you can access the files. For those of you who have written programs for file handling, you know that you can open a file, you can close a file, you can read from a file, write into a file. So, lot of functions are provided for accessing files. So, all these things are provided, you can use them as part of the file system. Okay. So, pictorially you can say that your file system is some kind of an abstract entity sitting in the middle. As a user, you need not worry about how a file system is, how the data are getting stored, how it is managing the data on the disk. You need not think about that. What you are more concerned is, I have some files, how do I access those files? Because as you know, typically every file we create, we give a unique name. Well, of course, we can give the same names to two different files also, provided they are stored in separate folders. So, the files are created with some names. There are different types of files, as you know, they are getting stored, and the file system will allow you to store these files on the disk and also provide a mechanism using which you can access these files, and operating system will be providing that service. It can be Windows, it can be Linux, it can be iOS under Mac, it can be any kind of operating system. Okay? Fine. Now, one important question, when I say my file is getting stored on the disk, just like when you discussed memory management, we say that a program is loaded into memory. So, we ask, the question you ask is that where in memory, what is the memory address? In contiguous allocation, we are storing a program in one contiguous part in memory. In paging, we are dividing my program into pages. These pages are loaded into page frames. The address of each page frame is known, that is stored in the page table. So, somehow we have a mechanism to find out what is the address in the physical memory where I can get the data. Similarly, when I store a file on a disk, I need to know where exactly in the disk my data is, because in the disk also you know that there are surfaces, there are tracks, there are sectors, where exactly. So, you see, conceptually if you think of a file, suppose this is pictorially I am thinking of a file, the file can be large in size. So, with respect to a file system, a file is divided into some chunks. Just like in paging, we divide a program into pages. Here we divide into chunks, and these chunks are called blocks. These are blocks, and block is typically a collection of sectors. Let us say 4 sectors, 16 sectors, 32 sectors, that constitutes a block. So, in a file system, when you do a read or write, you do it block wise, not sector wise. Sector wise is a low level input output mechanism for the disk, but with respect to a file system, you are thinking about blocks. So, in a disk, the lowest level data transfer unit is the sector, but for a file system, the minimum or the smallest unit of data transfer is a block. And as I said, a block size will be equal to some number n multiplied by sector size. The value of n can be decided at the time you are creating the file system, that how big you want the block to be. Okay. Now, one intuitive thing is that when you organize these sectors into a block, the idea is that the block can be accessed faster. So, the question is, how are the sectors inside a block typically organized? These are just some typical things I am telling you. In a file system, it can vary from one file system to another. Well, either you can allocate consecutive sectors on a track and call it a block, because once your read write head is on a track, all the sectors will be read one after the other very quickly. You do not have to move the head anymore. So, seek time is required only once. Or if you have platters, you think of the concept of a cylinder, all your read write head is on top of the same track, same sector. So, all those sectors, that set of sectors, if you call it a block, then all of them can be read in parallel, they can be written in parallel. So, same sector numbers on the different disk surfaces. So, if you do something like this, then access of a block will be much faster as compared to accessing the individual sectors of a block, just assuming they are stored randomly, they are stored in any random locations. Okay. This is how you can speed up the access. Now, some of the typical operations that you can carry out on a file, these are something which the file system provides you, and also the operating system interface that is provided to the user that supports these things, because operating system provides some facilities to the user, and operating system in the back end is calling the file system to get these operations done. Okay. See, some of the very common things which you normally do: create a new file. Normally you use a editor to type something and save it into a file, a new file gets created. Read data from a file. Whenever you open a file using an editor, you can see the contents. So, actually you are reading from the file. Then you make some changes, you save, you are doing a write into a file, writing data into a file. But there is something which normally you cannot see. There is something called a seek. When you do a low level file access, suppose you write a program in C or C++ to access the data in a file. Normally what you do, you open a file, you start reading the file from the beginning, byte by byte or word by word, like that. But if required, you can directly go to the 1000 byte of the file and start reading from there. This is an operation called seek. There is a function called seek, using which you can directly go to some particular position in the file and start reading or writing from there. Okay. Of course, you can delete a file, you do not need it anymore. When you delete a file, all the blocks it was occupying will be released. You can copy a file, same data you replicate into another file, give it a different name, rename a file, do not copy, just change the name of the file, data remains the same. And again, when you do low level file processing by writing a program in C or C++, at the beginning normally you have to open a file, after doing all read write everything, at the end you will have to close the file. So, these are some of the typical operations that are provided as part of the file system. Okay. Now, one thing let me tell you, there are various different kinds of file systems which have evolved over time. Starting from the oldest one, when Microsoft came up with the disk operating system MS-DOS, that was a very primitive kind of an operating system, and after that there have been many refinements. There can be various different kinds of file system, where I talked about the data structure to maintain information about the file. That data structure is somewhat different from one file system to another. Now, typically under Linux, if you say, there are so many different file systems which are available. So, you can see all of them: ext, ext2, ext4, t3, xfs, many different file systems are available. Even some files which you create under Windows, you can see that they are created using NTFS or some other kind of file systems. So, there can be other file systems also. But in a computer system, you may be having multiple disks or USB drives which have been created under different operating systems. So, you should have a uniform kind of an interface through which you can access all data from different file systems. So, on the right you have a general schematic how this is done. You have a file system interface through which all user programs interface. All user programs or the users, they access through the file system interface. The file system interface in turn, they access another layer called virtual file system interface, VFS. And virtual file system in turn have interfaces or special APIs for several different types of file systems. So, that way different kinds of file systems can be integrated together. These file systems can be on disk, it can be a remote file system also. Sometimes over a network, from a server, you can mount a remote file system on your local machine. So, you are accessing them as if it is a local file system, but actually data are getting accessed over the network. So, there are so many different kinds of ways you can access the file system, and this VFS interface provides a uniform interface for you. Okay. So, with this we come to this first lecture of this module, where we have been discussing on file systems. We tried to talk about the basic idea and the basic concept of the file systems, how it works, what are the basic features that a file system should have, the basic functionalities a file system should have. Now, from the next lecture onwards, we shall be moving into some of the other details inside a file system, the data structure that we talked about, how those data structures are stored and maintained. Okay. This we shall be discussing in our next lectures. Thank you.